In this video, we will examine 7 mistakes that must be avoided in the TNC system. To understand where these mistakes occur, and why they can be dangerous, we must first recall what fundamentally defines a TNC system. In a TNC system, the neutral conductor and the protective conductor are combined into a single conductor, known as the PEN conductor. In other words, the same conductor is used for both the neutral and the protective earth. It carries normal load current, and it also protects people from electric shock. This is why the TNC system has specific rules that must be followed. If you want to understand all earthing systems in detail, I have explained them in a separate video. Now, let us look at the 7 mistakes you must avoid in a TNC system. Mistake 1. Incorrect termination of the PEN conductor at equipment. In a TNC system, the PEN conductor must always be connected first to the earthing terminal of the equipment. A dedicated jumper is then used to connect this earthing terminal to the neutral terminal. This ensures the protective function remains intact, even if the neutral terminal becomes loose. If the PEN conductor is connected directly to the neutral terminal instead, any interruption at the neutral terminal will also interrupt the protective earth. This defeats the basic safety principle of the TNC system. Mistake 2. Providing a disconnecting device in the PEN conductor. In a TNC system, there must be no switching or disconnecting devices in the PEN conductor. Any such device would impair the effectiveness of the protective measure known as protection by automatic disconnection of supply. For example, if a switching contact in the PEN conductor fails to close properly, a short circuit to an exposed conductive part may not result in automatic disconnection. As a result, exposed conductive parts could remain energized. For this reason, the PEN conductor must be highly reliable, both electrically and mechanically. Mistake 3. Using a PEN conductor with insufficient cross-section. Standards do not permit the use of a PEN conductor with a cross-section less than 10 mm squared copper or 16 mm squared aluminium. Below these values, the conductor is more likely to break under mechanical stress. Such a failure can result in the loss of the protective function and create a serious risk of electric shock. Mistake 4. Using a TNC system downstream of a TNS system. The TNC and TNS systems can be used in the same installation. This arrangement is known as a TNC system. However, a TNC system must never be used downstream of a TNS system. If the neutral conductor is accidentally interrupted in the upstream TNS section, the protective conductor in the downstream TNC section would also be interrupted. This would expose users to a serious danger. Mistake 5. Using RCDs in TNC systems. Residual current devices cannot be used in TNC systems because the neutral and protective functions are combined into a single conductor. An RCD cannot correctly detect a residual current. As a result, RCDs are not permitted in TNC systems. If RCD protection is required, the system must transition to TNCS or TNS in accordance with IEC 60364. Mistake 6. Using TNC systems in premises with a risk of fire. As explained in Mistake 5, RCDs cannot be used in TNC systems. This limitation has an important consequence. In many installations, RCDs are used not only for protection against electric shock, but also for fire protection. Since RCD-based fire protection is not possible in a TNC system, insulation faults may remain undetected for long periods. This increases the risk of fire. For this reason, TNC systems are forbidden in premises with a risk of fire. Mistake 7. Using reduced cross-section PEN conductors where third-order harmonic currents are present. Modern electronic equipment, such as computers and UPS systems, produces triple-N harmonic currents. These harmonics flow in the neutral conductor and add up. In a TNC system, the PEN conductor carries both neutral current and protective current. If the PEN conductor has a reduced cross-section, these harmonic currents can cause overheating and increased fire risk. For this reason, reduced cross-sections for PEN conductors must be avoided. The PEN conductor must always be dimensioned for the expected harmonic current. We will cover the dimensioning of neutral or PEN conductor, considering third-order harmonic currents in a separate video. All these mistakes happen when the protective role of the pen conductor is not respected. When this principle is ignored, the TNC system becomes unsafe. The TNC system can be safe, but only when its logic is respected and its limitations are fully understood. Thanks for watching.